Flux, also known as luminous flux or luminous power, is the perceived amount of light received from a light source. It is a value determined from the amount of luminosity that is received of 1 square meter at a distance d from a light source. So the flux is given by the symbol F, and that is equal to the luminosity at the source. So here's an example of the sun, and here is the earth, and the sun and earth are separated by a distance d. So we wanted to find out what is the flux F that is received on 1 square meter of the earth's surface. It could be over here or on this side. 1 square meter of the earth's surface at a distance d from the source. So here's the source. The source is being emitted from the surface of the sun, and it has luminosity L. L is always defined at the surface of the source, and it never changes. So it could be 1 solar luminosity. We want to find out of all of this light, because the light's being emitted in a spherical direction, we want to find out how much of this spherical light is landing on 1 square meter at the earth. And that's going to be the flux. So the light spreads out in all directions in a sphere. So out here, we have a sphere that's outlined with this dashed line, and that sphere's area is equal to 4 pi d squared. So you need to find the distance to where you want to find where the flux is going to land, and the light's going to spread out into a sphere, so you need to find the area of that sphere, which is going to be 4 pi d squared. So the equation of flux is always luminosity at the source. So the luminosity is at the surface, but then it's going to be divided by the area, which is dependent on d, which is how far away you are from that source, because the light spreads out. Let's look at an example of this light spreading out. So once again, here's our S, that's our sun, that's our light source, and it's just a point here, so I'm going to put the letter L there. That's where the light's being emitted. And then the light is spreading out, and so we're just looking at a little cone area, solid angle cone area that the light's being spread into. We want to find out this 1 square meter area, what's the flux landing on it? Well, the flux is always equal to the luminosity divided by the area. The area is always defined as a sphere, which is 4 pi and that distance squared. In this case, distance is given r, so the luminosity divided by 4 pi r squared gives you the flux on this 1 square meter area. Now that light continues to shine and spread out even further. So we want to find out what's the flux now at a distance of 2r on this 1 square meter. Same size 1 square meter as the previous one. But now we want to find out what's on 1 square meter over here. Once again, luminosity is divided by the distance, 4 pi, the spherical area. Now the distance went 1r, 2r, so our distance is 2r squared. Same thing, the light continues to spread out, and notice we have fewer and fewer light rays passing through 1 square meter as we step further and further away. So now we want to find the flux at a distance of 3r. So now we're at 3r. The flux is always the luminosity, the surface of the source, divided by the area, and the area is always defined as 4 pi d squared. D in this case is 3r, so it's 4 pi 3r squared. This is how you find the flux. The light spreads out in a sphere, and that sphere gets larger and larger and larger as you step away from a light source, and so the flux, or the amount of light that is received with increasing distance, is lower the further you are away from the source. And this explains why on a dark night on a 2-lane road, you can't see, on a straight road, you can't see the car approaching you with its headlights on. It's only as it gets nearer to you can you see the light from this faraway source, and it'll appear dim. As the car gets closer to you, the light source will appear brighter because the amount of flux that's being received is greater because you're getting closer to the light source. So flux, also known as luminous flux or luminous power, is always the luminosity at the source divided by 4 pi d squared, where d is the distance that that light is spreading into a sphere.